Okay, during our last video, we talked about capacitors being used in tone stacks, and that one of the cool things about capacitors is capacitors allow higher frequencies to pass, but they block bass frequencies or treble frequencies. Okay, now one of the things to know is when you combine a resistor with a capacitor. So in this case, you have a capacitor going to ground. Remember, I said ground is 0 volts. And you have a resistor leading up to that capacitor. What that does is it creates a filter called a low pass filter, which means that it's going to allow low frequencies to pass, but it's going to cut down the volume of treble frequencies, because the treble frequencies can pass through this capacitor and go to ground, but the low frequencies can't go through the capacitor, so they pass through. Now, what's important about this is it allows us to control what frequencies move forward in our circuit. Okay, and this is going to be important in terms of setting up our tube to be an amplifier. But just know that we could use a combination of a resistor and a capacitor to ground to keep our low frequencies, or we can use a combination of a resistor to ground and a capacitor to keep our high frequencies. And based on what resistor and what capacitor we use, we can actually select the frequency at which it starts turning down the volume of your signal. Okay, so this is a little calculator that's helpful on DigiKey. So you can actually take a look at a capacitor and a resistor, and it'll start to tell you what frequency is going to cut the volume of your signal by 30%. Okay, so we're going to come back to this calculator, and then I'm going to reference that as I talk about the parts that you need to set up a tube as an amplifier. Okay, so here I have a schematic for our Tweed preamplifier. I'm going to move this over just a little bit, and I'm just going to focus on the first stage of this tube amplifier. Okay, so this is our input jack. So our input jack signal comes through the tip of the jack. Okay, the shield of the jack, or the metal part of the jack that touches the outside of your guitar cable, is connected to ground or 0 volts. Okay, now remember I talked about the fact that ground is 0 volts, and once our guitar signal gets there, we're not able to have it go forward through the circuit and make it to the output of our circuit. So at the very beginning of this circuit, we have a resistor to ground that's 1 meg ohm, which is a very large resistor. So we are making it extremely hard for our guitar signal to go to ground. So we are trying to keep as much of our guitar signal as we possibly can. Okay, the other thing that we're doing is we're also providing, we're tying our grid to ground. We're making our grid 0 volts. Now, the reason that we're making our grid 0 volts is that what our grid does is it controls how much our tube is going to be amplifying our guitar signal. Okay, as we mentioned before, electrons are negatively charged. Okay, so if we give our grid a positive voltage, we can have no guitar signal going through this thing, and our tube is going to be pulling electrons up to the plate like nobody's business. And if tubes try to push too much current, they blow up. So one of the things we have to do at the outset is to tie our grid to 0 volts so that it has a starting point where it's not trying to blow the tube up with current. Okay, so that's another purpose for this resistor. This resistor is called the grid leak resistor. Also, another function of the grid leak resistor is we have electrons coming up off of this cathode, as we explained before. Now, since this is a piece of wire that's inside the tube, what can happen is electrons can actually get stuck on this grid. And the more electrons you have on this grid, the more negatively charged this grid gets. And as we mentioned before, similar signs or same sign particles are going to repel each other. So if I build up a lot of negative charge on this grid, what's going to happen is it's going to repel the electrons from coming up, which are going to reproduce our guitar signal. And that'll keep the tube from amplifying our guitar signal if this grid gets too negative. So if a lot of negative charge gets built up, it gives this negative charge a path where it can bleed off to ground and allow it to maintain it being at 0 volts. So we can continue to have that amplification process continue to happen, okay? Now, we have another resistor we have here. This resistor is called the grid stop resistor. Now, the purpose of this resistor is that it combines with the tube to create a filter that is going to filter out all of the parts of our signal and the noise that may be coming in through this guitar jack from getting amplified. Our ears stop hearing sounds at 20,000 cycles per second, okay? Now, we don't need to reproduce any of that or have it pass through our guitar circuit. We don't need to waste any of our power on that, okay? So what we do is we use this grid stopper resistor to create a filter. Now, how exactly is it creating a filter? Now, when we talked about capacitors before, we said that a capacitor is nothing more than our signal going through one wire and another wire being parallel to it, right? With some sort of insulator in between. That insulator could be air. The insulator could be some sort of material that just does not conduct electricity. So if you take a look here between the grid and the cathode, we have a signal coming through here, and we have a cathode that's being tied to ground. Those two parallel pieces of wire create a capacitor, okay? Now, for a typical, this is a 12AX7 tube that you see in a preamp. With the way that it's set up here, we can ballpark a figure for our capacitor of about 100 picofarads. Remember, I said you can measure the amount of energy a capacitor can store in a unit called farads. And we have a 34K resistor here. So what I'm going to do is I'm going to put that into my low pass filter calculator to tell you at what frequency is going to start turning down the volume of any signal that comes through. So one thing to note about radio signals are really powerful and come through antennas and receivers. Those signals are all around us, and those signals can actually make their way into your guitar amp, and they are higher than the range of human hearing. That's why we can't hear the radio without it actually being connected to a radio itself. So we're going to take a look at that calculator that I talked about, and we're going to switch this to a low pass filter. Our tube is acting like a capacitor to ground, okay? And we have our grid stopper resistor here. So our grid stopper resistor is a value of 34 kilo ohms or 34,000 ohms, and the capacitor of this resistor is 100 picofarads. And this is 100 microfarads. We're going to move this to picofarads. Okay, so as you can see, it's going to start cutting off. It's going to start cutting off by 30% at the frequency of 46,000 cycles per second. Okay, and as we said before, our hearing stops as humans when we get to the frequency of 22,000 cycles per second. Okay, so that's what that resistor is doing for us. One of the things to note is that the larger this resistor is, the more noise we get into we get from our circuit. So one of the things to be aware of is that we don't want this resistor to be too large, because the higher the number of ohms we have in that resistor, the more noise we're going to create in our circuit. Okay, so that's the purpose of this resistor, the grid stopper resistor. Okay, we have another resistor here called the plate resistor. Okay, now as we mentioned in our tube, we need two types of voltages in order for a tube to work. We need a high positive voltage to be able to draw those electrons that get pushed out from our cathode. We need a high voltage up here, and we also need a low voltage and a high current that is going to heat up the piece of wire in this tube, which is going to heat up the piece of wire in this tube called the filament, and that is going to heat up our cathode and cause the electrons to boil off so that they can get attracted by our plate. Okay, now what this resistor does, this resistor has two functions. Okay, so as we said before, the guitar signal will control the amount of current that is coming through the tube. Okay, what this resistor does is it allows us to convert the current that's going up and down to a voltage that's going up and down and getting amplified. That's what this resistor does. Okay, this resistor also allows us to control the amount of gain that is in this stage. Typically, the larger this resistor is, the more gain that we're going to get out of this stage. Okay, the other thing that this resistor does is, remember, whenever we have a resistor and we have a voltage that's being applied to that resistor, the voltage is going to drop. Okay, so what this resistor does is it allows us to control the amount of voltage that's coming to this plate. That's pretty important, because each tube has a maximum voltage that you can put on the plate while it could still keep working. If you have too much voltage on a tube plate, it could cause your tube to burn up. So it allows us to control the amount of voltage that we have on our plate. Okay, and we could take a look at that. Now, you may have a question: how exactly do we get this low voltage that we can feed to the filament of the tube to heat up our cathode, right? And to get a high voltage in order to charge our plate with a high positive voltage and attract those electrons coming from the cathode to amplify our guitar signal. How we do that is we use something called a power transformer. So what a power transformer does is it plugs into the wall and it steps up our voltage. So it steps up our voltage here. We get about 120 volts from the wall. This specific power transformer that I'm using will give us 240 volts on the other side of the transformer for our plates on our tubes, and it'll convert 120 volts to 6.3 volts, which is the exact voltage that we need for our tube. That's the low voltage that's going to heat up the filament, heat up the cathode, and get those electrons going. Okay, so that is the function of our power transformer, and that's why we have power transformers even in our preamps. Now, as I mentioned before, it's important to keep this grid negative. Once we get this grid going positive, what happens is we have nothing repelling the flow of electrons coming from our cathode to our plate. We can't control the current. We get too much current and our tube blows up. Now, we don't just have to tie this to ground. That sets this at 0 volts, but actually we have fine-grained control over how much current we want to have flowing through our tube. And the way we have fine-grained control over that is with this resistor, which is called the cathode resistor. Now remember, we said whenever we have voltage applied to a resistor, we get a voltage drop. So I'm going to zoom out a little bit, and you can see that this resistor is tied to ground. Okay, so if we have a voltage, that we know that ground is 0 volts. If we have a voltage being applied to this resistor, we know that we're going to have a drop in voltage. Let's say we have a drop in voltage of 2 volts. Okay, so if we have a drop in voltage of 2 volts, we're going to have negative 2 volts at this point because it's going to drop the voltage from 0 to -2 volts, okay? So what that does for us is it allows us to determine, again, how much current our tube is going to flow even when we have no signal attached to this. The more negative this voltage is, the less current our tube is going to flow without a signal being attached to it. Okay, so the size of this resistor is going to control that. The larger this resistor is, the higher the voltage drop, and the more negative our grid for our tube is going to be at default. Okay, now remember we said that we're going to have current flowing through here that's going to cause a voltage drop. That current comes through here and gets boiled off of our cathode, and those electrons, that movement of electrons, comes up through our plate in order to move on to the rest of our circuit and into our tone stack. Okay, now this resistor is being used to drop the voltage and set how much current this tube is going to use. However, we don't want this resistor to get in the way of amplifying our guitar signal. So the way we increase the gain of this stage is with something called a bypass capacitor. Now, one of the things to note is that capacitors will pass signal from our guitar, but it will block DC voltage. What is DC voltage? So DC voltage is the type of voltage that comes from a battery. This voltage does not go back and forth, positive to negative. This voltage just stays positive or stays negative, okay? Which means that the frequency of the current at which it goes back and forth is 0. As we said before, capacitors block low frequency content, okay? The frequency of DC voltage is 0. So what that means is that it blocks any DC voltage from going through the capacitor. It's forced to go through this resistor, which helps us to set the amount of current going through our tube. But it allows the signal that's getting amplified from our grid, right? The grid is controlling how much electrons are flowing back and forth. It allows that signal to go through the capacitor, flow through the capacitor and up through here, touch our plate, and go through the rest of our circuit. The larger this capacitor is, the more low end we amplify and allow to pass around or bypass this resistor. Okay, so there is I'm going to look this up real quick. There is actually a bypass capacitor calculator that you can use to tell you at what frequencies you're going to see your signal amplified. So bypass capacitor calculator. Okay, so all you have to do is put in the frequency that you want to be filled out, what resistor you're using for your cathode bias resistor, and it will tell you what value you should have for your cap. So let's say we want to filter out, we want to filter out 40 hertz. If we think about it, 40 hertz is 1 octave below the lowest E you can play on your guitar, which is 82 hertz, 41 hertz. And let's say in that circuit before, if we take a look at the schematic, we had a 1.5 kilo ohm resistor. So we're going to put 1.5 kilo ohms. Click calculate. And it's going to say it needs to be at least 26 microfarads to bypass the frequency of 41 hertz. So you could use a calculator like this to tell you, as I mentioned before, hey, how big does your cap need to be in order to bypass certain frequencies that you don't want amplified in your circuit. So the other thing to note here is we're going to talk about this capacitor. So this capacitor also has a role in your circuit. Remember we said that around here we need a pretty high voltage in order to have your plate attract the electrons that are coming off of your cathode, right? So we have about 250 volts here, okay? Now, if we take a look and we go further down our circuit, that voltage is coming in here to the grid of our tube. As we mentioned before, if we have a positive voltage here on our grid, it is not going to restrict the flow of electric current through this tube, and the tube is going to blow up. As we mentioned before, capacitors block low frequency content, okay? DC voltage is voltage that has a frequency that's 0, okay? So what this capacitor is doing is it's blocking the DC voltage that we're using to be able to have our tube set up for amplification. So the only thing that's passing is our guitar signal once it makes its way through this cap, because capacitors pass our guitar signal, which is an AC signal. It fluctuates from positive to negative, positive to negative. So that is the purpose of this capacitor. Also, if we take a look at this capacitor, there's another formula that you can use to calculate at what frequency your capacitor is going to start blocking that low frequency content. So there's a calculator you can use. You could call it a coupling cap calculator. Okay, so you can use this calculator here from Ant Books. If you click here, what it's going to ask you is, hey, this is set up for a 12AX7 stage, so you can leave these values that you have here. This volume control that we have here in our specific amp is 1 meg, so that is 1,000 kilo ohms. This is the value of the capacitor. So I have a 0.1 UF there, so I'm going to put 0.1 UF. This is asking, hey, what setting do you have your volume control at? This is halfway. So we can click on recalculate, and this is telling us that our coupling cap is going to start attenuating signals that are at 10 hertz or lower. So it's going to pass any guitar signal that you put through it, and it's also going to pass any bass signal that you put through it, because your bass's lowest note is going to be around 42 hertz. Okay, so that is pretty much how a tube works and how you can put components around the tube so you can amplify signals coming from that tube, and how you can also control what kind of tone is coming through that tube, how much treble, how much bass, and how bypass caps and coupling caps help you to control that. I hope that this was helpful. I truly do this for the culture. I want there to be more black and brown amp builders out there, so this is why I make this content. Peace, y'all.